Yeah, bruh, look at the ugly problem right here, man. Bruh, I'm looking at the problem like, bruh. The mass of an isotope decreases at a rate that is proportional. I've seen this before. Is proportional to what? A rate that is proportional to a mass. The mass is your amount, and this is your derivative. Derivative. Okay. All right. So if that's our okay. So here we go. The isotope. Should we use the I? No. Let's use M. dm. dm. dm dt, I think, yeah, it's at that time, so it's with respect to time, is proportional to, so I'm going to say K, and then mass. All right, it's proportional to its amount. Okay, copy that. All right, it says the mass of the isotope was 40 grams initially. Oh, there's that word. And it was 10 grams after 16 days. All right, so let me give you the long way, and then I'll show you guys a quick little shortcut. Okay, so first, let's do our differential equation business. All right, I moved the dt to the other side. Now I'm going to move the m to the other side by dividing by m. When I divide by m, that's the same as multiplying by 1 over m. Now I'm going to integrate both sides, but let's clean it up. We have 1 over m dm equals k dt. So what you do next is you integrate both sides. Ooh, what an ugly integral sign. On the left side, we get the natural log of m and the absolute value of that. And then we get a constant because we are integrating with an indefinite integral. And on the right side, we have k times t. And then you have your constant. All right, let's combine those constants together to get c sub 3. And now we have m almost alone. Let's keep going. So we have base e. So I'm raising this. This is now an exponent. This is now an exponent. On the left side, these cancel out. I'm left with m. Yay! And on the right side, we have e to the kt. And we're going to multiply it by e to the c sub 3 because I see this is just a constant. And I want to simplify this a little bit more. E raised to the c sub 3 is just another constant. So we're going to write c sub 4 e to the kt. All right. Now, this is a function of t, so I could put that. I could put a t next to the m right there because it's just saying that I am plugging t's into this function. So what I need is I need a c sub 4 and I need a k. All right, now this problem does call this the initial amount. And that's where our shortcut comes in. But before I do our shortcut, what that means is that when we have no time, we are starting with 40. That's just what it is. It's 0, 40. It's a point. 0, 40 is the initial amount. Then there's the other information. We have 10, 16 days. Oh, so time is days. After 10 or 16 days, okay, so we plug that into m. What would we get? We would get 10 grams. So that's 16 comma 10. All right. So we have 2 points right here so that we can find our missing variables. But check this out. If I plug in that 0, like this guy right here, into this t, we would get c sub 4 e raised to the 0 power because k times 0 would be 0. And what is anything raised to 0 power? Oh, no. You guessed it. And then on the other side is 40, right? When we plug in 0, m is 40. So we know that c sub 4 is 40. Now I can rewrite the dude. I can say m of t equals 40 e to the kt. Okay, we still have 1, 2, 3 variables, and we need to only have 2. We need to know what that k is, and that's where this other point comes into play. So I'm going to put 10 in there for the m. For the k, that's what we're looking for. For the t, I'm going to plug in 16, and now I get to solve it. So I divide both sides by 40, and I get 1 over 4 equals e to the 16k. Now, if I want to get that k out of the base e, I need to natural log both sides. So I'm going to go ahead and natural log both sides right there. On the left side, I have natural log of 1 over 4. On the right side, those things cancel out. I'm left with 16k. Then I have to divide both sides by 16 so that the k gets alone. We found our k. Now, this is what we got. We have m of t equals 40 e, and then we have our k, which is kind of nasty, but we got to write all of it. Natural log of 1/4, and that whole thing is being divided by 16, and we're multiplying that by t. All right, now we have our function. Now we can plug in 20 days and we can find the exact answer, the more exact answer. So this is what I'm going to do. I'm going to plug all this into a calculator, and in the T, I'm going to plug in 20. So let's get out of here. Let's get our Desmos up. Now, I'm going to do Desmos and I'm going to do a normal calculator so you guys can see what it looks like. But Desmos is going to be available for the AP exam now, so I'm going to show it to you guys there too. So 40e raised to that nastiness. Okay, so 40. Wait, where'd you go? 40. And then we got to do an e. So I'm going to go over here, go e. And then I'm going to go back to my numbers. How do I get back to my numbers? Oh, there. Press that. And then I'm going to raise it to, now sometimes like if you're on your keyboard, you can use the caret sign. And then I always use parentheses in the exponent. It makes my life a little easier. And now I need a natural log. So let's see, where's my natural log at? Is natural log in here? I don't know if natural log is in here. I could just type ln. It probably is. Oh, there it is. But I know you can type ln. And I think, what was it? 1/4, 1 divided by 4. Then close that parenthesis. Nope, not right there. I got to get out of there, out of that fraction. Close that parenthesis, and then I got to divide that by, what was it? Divide it by 16, and then multiply it by 20. All right, I don't know why it said 2, but divide by 16, and then I'm going to get out of that, and then multiply it by 20. All right, look, there's our answer, 70.07. What does it say round it to? Round it to the nearest gram. Now over there I got m of 20. It's supposed to be a 20 right here. M of 20 equals 7 point, oh, I forgot already. 7.07. Nearest gram would just be 7. Okay. Now, what if you wanted to use your graphing calculator? What would it look like? It would look something more like this. Okay, let's clear out of this. So we have, I think it was 40. Then we have times e, so second ln will give us the e. And then in our exponent, we have a natural log with 1 divided by 4 in it. Close that parenthesis, then divide that by 16, and then multiply that by 20. All right? It should get the same answer. Yay, we did! Oh my goodness, we are so awesome. Okay, that's how you do it. But wait a second, I wanted to give you guys a quick shortcut. The shortcut is this. You don't actually have to plug in the 0. If they tell you that you have an initial value, or if they say when there's 0 days, you get 40, then you can go right to the template right here. The template says, it's kind of like, what's that called? Continuous interest, compounding continuously. I think that was like amount equals the principal. Now, sometimes you use P, but whenever you use not, that means the little baby 0 right here. That means initial or starting amount. And then you have E raised to the RT. And the R is your rate. In our case, we were using K. And so if you know the initial, you can not have to plug in the first point. And you can just take that that initial amount and put it straight into your template because you know that this is an exponential function because the rate, which in our case was dmdt, was proportional to the amount. Okay, from the very beginning. But you would have to plug in 1 point. In this case, it would be 1610 so that you can find the R.